All right, Carlene, thanks for adding. That looks like New York, maybe during Christmas time, or the holiday season, I should say. All right. So since it is 1:30, we could go ahead and get started. My name is Rob Hampton. I'm a customer success manager for Blackbaud. I focus on the nonprofit area. Um, and we are going to be joined here, or we are joined here by Thomas Betts. And my role here is I'm going to have fun here in the chat and the Q&A session. So if you have anything during Thomas's presentation, I'll try to collate things, and he'll definitely also keep an eye on the chat too. But I'll try to collate things the best I can for you, Thomas, and raise any questions, concerns, comments, all that kind of fun stuff. Or if there are any fantastic GIFs that we want to acknowledge, we'll do that too. But I'll hand it over to Thomas. You could introduce yourself. I'll go off screen so I don't distract anybody. But yeah, I'll just hand it over to you.
All right. Well, thanks, Rob, for the introduction. I saw somebody already pointed out they love the title. So everyone, welcome to the Diamond Age, or a Young Developers AI Primer. Now, yes, I gratuitously stole the title from the book by Neil Stevenson. The subtitle of A Young Lady's Illustrated Primer is something that I've wanted to riff on for years, and this just seemed appropriate. If you're not familiar, that novel is set in a future where nanotechnology is everywhere. And as a reader, you just take it as that's science fiction, that's fine. But imagine if that was your reality. Then what would you call it? Well, I love this classic quote by Arthur C. Clarke that any sufficiently advanced technology is indistinguishable from magic. And right now, that magic is called AI. And artificial intelligence is a great umbrella term because how does it work? I don't know, it must be magic. And if we dig into it, sometimes we still wonder, well, how does that work? But just because we can't define AI, that hasn't stopped us from seeing AI show up in just about everything. How many products are you looking at these days that have the enabled by AI or powered by AI on it somewhere? So we've got our CEOs and our product owners, and everyone's adding, getting out the spray can and adding AI to everything. But just like that spray can of paint, if you don't know how to use it accurately and appropriately, you can make quite a mess. And I think we need to get intelligent about how we're using artificial intelligence. And today I want to cover a little bit about what that actually means. What are the actual terms and the building blocks we can use to build AI solutions that are actually meaningful? So again, good afternoon. I'm Thomas Betts. In my day job, I'm a software architect for Blackbaud. I work on Financial Edge and most recently Payment Assistant, if you're familiar with that. In my spare time, I do some work for InfoQ.com and the QCon software conferences that are international. I can't take credit for a lot of the stuff I'm talking about because it is information I've gained from speaking with industry experts about what they know about AI and other technologies. But one of the core values of InfoQ and QCon is being information Robin Hoods. We like to gather that information and share it with a broader audience. And that's kind of the inspiration of doing this presentation today. If you can't remember all those details about me, here's the CV that my mom just tells people I do stuff with computers. Now, one of the privileges I have that I get to enjoy every year is putting together the InfoQ Trends Report for software architecture and design. We use a framework that was created by Jeffrey Moore called Crossing the Chasm, and it was used to track trends like how are smartphones being adopted. And for software architecture, it's not quite the same as product adoption because any type of technology might not be applicable for every situation. But we use this to differentiate between the things that are really new and innovative and rapidly changing versus the stuff that's kind of settled down and everybody who wants to use it should now have an established path of how to do it. And I point this out because you can see there are AI trends that are all over the graph, stuff that's fairly established and stuff that's still rapidly evolving. And this report just came out in April. there are already things that we'd be adding to it if we did it again in June. So a little bit about what we're going to do today. I want to focus on those key questions. What is AI? We'll talk about what AI is and some of what it isn't. I want to get past just marketing and hype phrases and talk about real software. And that real software can be broken down into some common building blocks, just like the Lego sets behind me. You buy a set and it has all these blocks. You don't go in and buy one finished thing, just like you don't just buy AI. Because once we know what those building blocks are, now we need to figure out how do we use them? How do we put them in our software? And if we see them we see AI as a label on software, what's inside it? And I also like to point out if there are things you should do, there's probably things you shouldn't do. So I'll cover some of those cases as well. Oh, I have to put this disclaimer in all my presentations. There are a lot of facts and knowledge that I think people should know, but some of this is a healthy amount of opinion sprinkled in because there's some things that I think we as an industry should keep doing, or maybe we should stop doing, or even slow down, or at least slow down. So let's get to it. What is AI? Artificial intelligence, it's just a marketing term. There's nothing, it means nothing. I did warn you there'd be opinions. But in all seriousness, AI gets thrown around when we don't have a better term to describe something. It's that magic that Arthur C. Clarke was talking about. Once a widget becomes a known entity, whether that's a process or some code or a product, we give it a name. When you see AI, that usually means we don't have a more specific name for something. And that's one of the key points I want to get today. When you see that AI-enabled sticker on a product, I hope you'll be able to determine what's actually happening beneath that label. Now, I gave that spray can analogy before when business leaders and CEOs are saying, hey, we need to have AI in our product to look innovative. Well, let's look at a different analogy right now and say, instead of I want to see AI, what if those business people came to me as an architect and said, hey, we need to have a database in our system because a DB sounds really innovative and new. Well, if they came to me, I would turn back and ask them, what type of database do you want? And they'd say, well, you're the architect. You're supposed to tell us what database do you want? And I say, aha, I am the architect. I know the answer to that question. It depends. And the thing about a database is we know how to do the trade-off analysis. I can go back and say, what type of product are we creating? What are the use cases we need? And then I can go through all of these different criteria that are pretty established from decades of using databases to figure out what's the right tool to put into our application. We know how to do that. But when someone comes and says, please add some AI to the system, I still can't turn around and say, what type of AI do you want? Because they're going to look at me and say, I want AI. You figure it out. Well, again, the answer is it depends. The problem is AI is pretty new. And so when I'm trying to figure out, well, what does it depend on? We have to go back and ask those business questions. What are you trying to achieve? And what are the right tools and technologies and building blocks that we can use to get there? And that's because it's still new. We don't always have the answers. We're figuring it out. Now, I'd like to look at even just 5 years ago, say 2020 and before, most people, for example, my mom who says I do something with computers, when those mere mortals talk about AI, they were thinking of science fiction, right? We have books, and movies, and TV shows, and all these things that have these AI characters in them. And I think there's some perception that that's what we have right now. But that's not what we have right now. That is artificial general intelligence, or AGI. We're not really that close to it. Now, some people will tell you we're never going to get there. We're never going to have artificial general intelligence. Some people will say it's 5 years away or 10 years away. That's not what we're talking about today. Come back in 5 or 10 years and maybe we'll discuss it again. Today, in 2025, when someone says AI as that blanket term, 90% of the time what they mean is generative AI, right? This is what showed up on the scene when ChatGPT got launched and everyone went crazy for it because it's generating a whole sentence or a story based on text that you gave it. It seems remarkable. That's generative AI. And we see it in products like ChatGPT or GitHub Copilot where it can write code for me. I think Gen AI is also the most common. I just want to get out the spray can and put some AI in it. And that's led to probably too many chatbots, most of them not that great, not actually useful. And Gen AI is also not just text. It started very much as text, but now we're seeing all these other media. So we're creating images and videos and podcasts and deepfakes and whatever it is. There's other tools that do Gen AI that's not just text. So that's what I mean when we talk about AI, we mostly mean Gen AI. So let's get into what are the building blocks inside Gen AI. Well, the first one, and really the core of most AI, is the broad concept of machine learning. Now, machine learning is a process, and the process goes through, and at the end of that process of doing some machine learning, we create a machine learning model, right? And Gen AI is just one specific application of machine learning. Now, the algorithms are far too fancy and complicated for me. I'm not a data scientist. That's not my specialty. So I like to think of machine learning as a very simple process where you take a bunch of training data, lots of data, lots and lots of data. That can be anything. You can train a model on anything. You can start with historic sales data or photos of animals or user comments. You take that and you feed it into a process of machine learning, and you give it some of the questions, some of the data, and you give it the answers that you know are right. And you say, hey, for this data, this is the right answer. This is a picture of a dog. This is a picture of a cat. This user is unhappy in their comments. This user is very happy in their comments. And that you're training a model, and it starts almost as a coin flip, right? Like yes or no, doesn't matter. But you keep running it through this process over and over again, and the algorithm inside gets refined over and over. And that can take hundreds or thousands or millions of processes. And eventually it gets pretty good at, you give it some data it hasn't seen before, and it's able to predict the right result at the other side. So after it goes through that whole process, the end result is a machine learning model. Now that sounds really complicated, but again, I try and simplify things down so that I know how to use them. And I see these machine learning models as just a simple function box, like treat it as a compiled library or an API you want to call. If I want to do a square root, I'm not going to write an algorithm to do a square root. I'm going to import a math library and say, give me the square root of 4, and 2 comes out the other side. And so these machine learning models, you can treat the same way. You give it some input, it spits out some output. Now, that's basically it. Those can be very complicated. Those can be, here's a textbook, or here's a picture of an animal, or here's all of our sales data for the month. But all it's doing is predicting it. And when I'm talking about prediction, this is coming down to statistical analysis. So in that output, it's not just this is the answer. It also gives you a confidence score. I'm 95% sure this is a picture of a dog, or I'm 50% sure it's a dog. Well, do you trust it if it's 50% sure? So then we can take that confidence score and use that as well as the output to say, hey, this is probably a dog, or we can't tell if it is or not. And then this ML model, this simple function box approach, that's true for everything, whether it's that image recognition or sentiment analysis or sales prediction models. And in Gen AI, large language models, right? I think everyone's familiar with the term LLMs these days, because a large language model is just an ML model where the training data and then the input and the output, it's words. Lots and lots and lots and lots of words, like read the internet levels of words. And LLMs are really just the latest generation of natural language processing. Now, bear with me for a minute. We're going to go down the rabbit hole a little bit on terminology. So natural language processing is a subfield of computer science. Again, actual computer science terms we're talking about. And it focuses on that interaction between humans and computers using language. And it makes the machines understand and interpret and then generate language that looks useful to humans. It's not just a bunch of random characters. It actually looks like the way humans would talk. Now, NLP does not require you to have an LLM. We have been working on NLP for decades. It has evolved over time. And you can train it on text or even voice data. And this is how early chatbots worked. This is how your voicemail transcription works. I remember signing up for Google Talk years ago, and the reason it was a free service is because they were just listening to everyone's voicemails and transcribing them and then asking you, the user, to say, was this a good transcription? And in early days, no, it wasn't. It was kind of comical how bad it was, but it got better and better. And that was the idea of let's just get more and more and more data thrown at it. Now, NLP, the current generation, we've gone from those simple machine learning models to something called deep learning. Now, deep learning is a form of machine learning. It's just deeper, for lack of a better term. It has more layers. So machine learning, think about the first layer as just a yes or no question, maybe. Is this a dog or not? Or maybe it's a scale of 1 to 10. Well, if you start having layers and layers and layers below that, and each layer can do the same yes or no question or the same scale of 1 to 10, all of a sudden you have this exponential growth in how complicated the model gets. So even just 3 layers starts being deep, but some of these talk about hundreds or thousands of layers. And at some point, when you're talking about that exponential growth, the closest analogy to how these things work when you're talking about deep learning starts looking similar to how the human brain works. And this is where we start getting into what we call artificial intelligence. Because if intelligence is how humans think, and we're building computer models that are based off of the same types of activities, that starts to become artificial intelligence, right? So how do we make these artificial brains work? We have artificial neural networks. So inside our brain, we've got all these neurons that are connected, and that's what helps us as humans make decisions and recognize patterns and solve complex problems. If you create a computational model based on that same thing, then it starts being able to do some things that are similar to how the human brain works. But at the end of the day, it's still just a prediction model. Now, neural networks are, again, a computer science thing that we've been studying for decades, and we're getting pretty good at them. But when we're talking about it can do pattern matching and complex decision making, it's still just predicting what's the most likely outcome. There's just millions of likely outcomes, so it seems like it gets some pretty good results. That's as far down the rabbit hole as I want to go. So let's go back and talk about this large language model and put it in our little function box. So as I said earlier, large language models, LLMs, are just machine learning models that were trained on words. Now, turns out computers don't really understand words, so you have to turn them into numbers because that's what we can do statistical analysis on. So that's when we go through this process of tokenization. Now, what's a token? In most cases, it's a word. Sometimes it's part of a word. That's how we can build up like different parts of words and sentences. But really just think about, it's close enough to think that you're going to send it a series of words, a series of tokens. You put that into the language model, and then the output, it's going to predict, here's the catch, a single word. It's going to predict one token. So if I say, finish the sentence, Mary had a, the output is little. That's all it does. It just guesses the next likely word is little. And you're going to say, that doesn't seem to be how I've seen ChatGPT and other tools work. Here's the magic. It takes that word that it figured out, adds it to what I gave it, feeds it back in through a process called autoregression, and it keeps going through this loop until it spits out a token that says, I'm done. And that's why these are somewhat smarter than the autocomplete on your phone, where you just keep tapping the next word and it'll just keep writing and writing and writing. So I say Mary had a, it says little, feeds in Mary had a little, it says lamb, goes through and says, period, end of sentence, we're done. That's how it works. Now, I think large language models are great, but as the name implies, they are quite large. Some of them are very large. And you're like, well, how big is large? What does that mean? There's 2 numbers that get thrown around. One is the number of parameters, and one is the size of the context. Parameters are how much data the model was trained on, and then context is how many tokens or words you can have in a working session. A good analogy for this is if you're going out to buy a new laptop, you're looking at the specs of how big is the hard drive or the SSD, it's maybe in terabytes, and then you have your memory, and that's going to be a much smaller number for your RAM. And that's parameters to context. So how much data is there that it can access, but how much can I work with in this one session I'm talking about? And so we have large language models. We also have small language models. And some of these are just fewer parameters or smaller context. And I'd even say that some of the early large language models from 3 years ago are now considered small by today's standards. And the reason I bring them up is because as the language models got bigger and bigger and bigger, as it went from GPT-3 to 4, and now we're working at 5, the number of parameters got really large. Now, there are some downsides to that. So I'm going to use another analogy, and I like, car metaphors, because it's easy to see if you have a car that's like an RV, that's not going to be great if you just need to go out and get groceries. If you need to go on a road trip and live out of your vehicle for a month, then yeah, the RV is probably going to be better than a Prius. But again, can you find something that's smaller and probably able to do what you need to do to solve your specific problem that you have in your application a little bit better? And then it's not just a matter of the size, because sometimes you can get a vehicle that's about the same size, but is far more specialized. An F1 car can go around a track a heck of a lot faster than any family sedan. And we see these types of patterns with language models as well, because you can fine tune a model, and that makes it more like that race car. You can say, I don't need this large RV sized language model that can do everything. I want something that understands nonprofit data or some more specific aspect. And that fine tuning is where you can take a model that exists and basically send it to grad school and give it extra special knowledge. I always like I need a paralegal for this because they can understand legal terms. They don't have to have a medical degree. So get the model that's just right and has the knowledge you want. And sometimes in this fine tuning, you can actually shrink the models to get them to not know about stuff you don't need it to know about. There's a lot of complications of how this works. The example I give is if you're putting in somewhere in your application a language model, and people can type in whatever they want, should they be able to ask about Taylor Swift and Beyonce? If that has no relevance to your application, then why do you need the large language model that knows all about both of those women? So if you can get a smaller model, it's going to cost less to operate, and it's going to be able to solve the answers better. But sometimes you do need the big ones. So I'm going to say, if you can find a smaller model or a fine-tuned model, use those. What I want to make sure you don't do is think we need to build our own models because we need something that's very specific for us. The costs involved in building a language model and the amount of data you need to have are usually enough to deter anyone from doing it and doing it well. It takes specialized knowledge. I'm not smart enough. I don't have a data science degree to build one of these things. And most places, if you're not working at an AI company, most of the off-the-shelf products you can buy are going to be good enough for your needs. So if I'm telling you not to build one of these things and you're going to use one, how do you use it effectively? And I want to keep going back to that analogy of this is a simple function box. It's a black box. So now we're not going to make our own. We're just going to have to figure out how do I use it as effectively as possible. It's got input and it's got output. I'm going to feed in the input to get the best possible output at the other side. Well, the first way you can start changing the inputs is what's known as prompt engineering. Again, this is a pretty well understood term by now, and I'm not going to talk about a lot of examples of how to do prompt engineering because you can find those courses and other tips online. But the concept is just that you're going to create instructions and modify your input to get better outputs. Now, I was talking to my family the other day, and my son is in college now. And when I was in college and Google was new, people had to learn how to use Google. And now you need to learn how to use prompt engineering. Like, it's just one of those skills that you're going to expect people to have. Like, people are going to have to be able to search the internet 20 years ago, and people are going to have to be able to do prompt engineering. How do I get better results rather than just typing in a bunch of words? Prompt engineering has the lowest barrier to entry, which means it's the easiest way to get better results, right? Every one of these LLMs starts with a prompt. That is the bare bones input. So if you can give better input, you're going to get better output. One of the benefits of using the really large language models is that context has gotten quite substantial. So if you have an entire grant proposal and that can fit copy and paste into the prompt, then you can say, please summarize this, and it'll answer based off of that versus please tell me how to respond to whatever grant proposal. And it doesn't actually know the details. So anytime you're able to give it more specific information in the prompt, that's going to lead to better results. Sometimes to get that information you want to put into the prompt, you have to do a lookup first to find the data that's applicable. And this is a technique called retrieval augmented generation, or RAG. And it's just a supplemental step that before I do the prompt engineering, or I'm going to change my prompt, I'm first going to find the data. And in order for this to work for most systems, you sometimes have to change how the data is stored to make it more easily accessible. So there might be some type of indexing so you can do that search effectively. But you take the data, you get it set up so you can search for it, like take all of your HR documents and index them somewhere. And then somebody asks a question that says, do we have a policy of pet insurance? You can go and find all the documents that have something to do with pet insurance, take the results from that, take the paragraphs from those documents, feed that in, and basically do prompt engineering from there and say, hey, these are 3 documents that reference pet insurance. What's the answer? And then it can generate an answer based off of that. And what's really nice is then it can cite its sources because you gave it the sources the first time. And that is one of those things that leads to better results because you don't have the hallucinations. You're able to track where did you get your answers from. And I have to talk about hallucinations because hallucinations are where the AI appears to just be making stuff up. That's a feature. That's in there by design. It's not a bug that we're trying to get away from. Again, Gen AI and all machine learning models are just prediction engines. You put in a series of words and you're asking it, what is the most likely response? There's always a likely response. It might not make sense. It might not be true. But the problem is these are so good at creating language that we can't tell a difference. You know, if a human is hallucinating, you can probably see their eyes dilating. The LLM doesn't look any different when it's lying to you or when it's telling you straight faced. It's quite the sociopath. But stop trying to anthropomorphize these things. This is software, and the software's job is doing statistical analysis of words. And it did its job. It predicted the next word. So it's never a source of truth. Don't treat it like that. And remember that RAG and prompt engineering, it doesn't prevent hallucinations. It just lowers the chance of them. Now, I have to say, when I was preparing my slides, I forgot how long the presentation was. So the agenda didn't have this on it. So I'm just calling it a bonus round. So there's a couple other items I want to add in. And then I think I did say in the abstract that I was going to talk a little bit about Blackbaud's intelligence for good strategy and some of the stuff that's underneath that label we peeled off. So other stuff that's kind of new and popular these days is AI agents or agentic AI. Now, people are looking at ways to automate systems. So instead of just, I type in text and you feed me a response like that chatbot, I have this business process and can I automate that? Well, that's where an AI agent comes into play. You can write code that takes the power of the LLM, that natural language processing, and maybe it's the language it's interpreting is your API or some other system that's interacting with. Just like GitHub Copilot can write code, these things can write an API call and say, oh, I saw this input. The next thing I should do is call this service or call that service or send this data there. These are fine. The advice I give around AI agents is you still need some sort of supervision. Just like if you have a bunch of new hire employees and they're able to do a few tasks independently, but if they have something that's above their pay grade, they have to talk to a supervisor. So the agents need supervisors. Now, those supervisors can be humans or they could be different specialized agents that are trained in supervisory questions. So when that prediction confidence score is too low, then maybe it says, hey, I'm only 70% confident in this response. I'm going to kick it to a human. But if it's above 95%, then just let it go through and make the decision. Another term, this was one of those things that didn't show up on that software trends report, was model context protocols. And MCP is trying to make a standardized way for how applications can provide that context to LLMs. Basically, it's there to enable those agentic workflows. The tagline is it's like a USB-C port for AI applications. This is still early days. I haven't seen if this is actually going to pan out or if it's just a lot of hype around how they think they can connect these things. But one of the challenges we're trying to solve is if we're trying to put all of these AI agents or different pieces of code together, and I have to write custom code all the time, how do I make it easier to determine what that code is? And so MCP is one of those ways it's going to be providing some sort of data that the LLM can go and interpret and then use for its decision making. Oh, last bonus topic, vibe coding. I think there's some ideas around what vibe coding is. And it's like people are just going to sit down and never look at the code and like just say, I want an application that does this, and it spits out, and then that's running in production. That's not really what was intended. The people who came up with this term were talking about it more like that jam session with your musician friends, that everyone just gets together and you start playing and you don't know where it's going to go and you learn something new. If you're going to turn software into production quality software, at some point you're going to look at the code. It can help generate the code, but this isn't replacing a programmer by just like talking to the computer. Again, that's like Star Trek level science fiction. So we're not there. So again, with the one little car analogy I like to throw out, if you saw a 5-year-old driving down the sidewalk in their Power Wheels, you wouldn't hand them the keys to the family car. These computers are not quite that good at solving all these things. They're not going to replace every software developer right now. So Blackbaud has been talking for a few years about its intelligence for good strategy. And I personally appreciate that it's not simply AI for good. It is intelligence for good. And what's great is under the banner of intelligence for good, artificial intelligence is just one quadrant on that map, right? We have all these other aspects of it that allow people to make intelligent decisions. And AI only happens when you have big data, right? That's the core of all this. To build these large models, you have to start with a lot of data. And then you can do analytics either directly on that data, or you can have AI tools like the Gen AI help you look at them. Now, one of the things that machine learning models have been great at is doing that predictive analysis. As long as you understand it's predictive. So if it says, hey, we saw these donations come in last year and we're going to predict this level of growth next year, it's not set in stone. You understand that's a prediction. But if you say, well, it came from the AI, it must be true, you're going to be disappointed. And that's not a Blackbaud problem. That's a industry-wide problem of anytime you use artificial intelligence. So that intelligence for good, make sure it's actually for good. So what are some of the examples of where we've got stuff in Blackbaud products doing AI? So the Just Giving Story Enhancer, this gets called out in the news a few times. And this is very simply prompt engineering on top of an LLM. Someone wants to do a fundraising drive. They go into Just Giving and they create their page and they write up their story. Now, as it turns out, most people who need to raise money for something aren't great writers, naturally. LLMs can be pretty good writers. So you can take, here's what I wrote, make it better. And there's a few buttons that help change the tone. And all we're doing is substituting in new prompts that take, here's the text, revise it with this format. So instead of you having to know how to do that, because you could do all that with ChatGPT yourself, there's just a little button to do it. But that's all it is under the covers. Those are the building blocks we're using. Where we've got predictive analytics, again, for donor relations and whatever else, this is because Blackbaud has this enormous collection of philanthropic data. And we can use that to train models. And those are, our big data. And so we can take those models and put them into our applications and look at customer data, at anyone's data, and say, hey, based on what we see in the industry, this is what the model says is likely to happen. But that's what it comes down to. It's not really so much an LLM, that's just machine learning. Blackbaud Copilot is another term that's getting thrown around. I pulled the quote directly from our product update briefing that says, Copilot is an AI-powered coach and assistant that allows you to interact with your data in natural language. Oh, look, natural language processing right there. Now, it also goes on to say that it's using a closed LLM to make sure that we have this data secure and it's not leaking out into some public API. And to make Blackbaud Copilot work, the engineers at Blackbaud are doing all the other techniques I've described. We're incorporating RAG or prompt engineering and integrating with the other APIs we have, the Sky API integration, to say, go and get this data. So if I'm on a record page, here's a donor, it can take the data that's on that screen, send that into a prompt and say, tell me more about this, tell me their history. And it can call other APIs because we've told that little bit of the Blackbaud Copilot, on this page, you can do these other things. If you were to just take a naive approach and put the chatbot out there without teaching it all that stuff, it won't actually be that useful. So some key takeaways. I want everyone to be able to take the AI hype, put that aside, and realize when we're talking about software has these real world components. And if you can't figure out what they are, it might just be AI hype. Prompt engineering and RAG are the great options. They can improve the results from any LLM. So always think about how you can ask better questions, provide better input, you will get better output. And the biggest takeaway really is that Gen AI is a prediction model. Never treat it as a source of truth. Those hallucinations are a feature, not a bug. Now, I started off by quoting Arthur C. Clarke's third law, which is probably the most famous, but I want to wrap up with Clarke's second law. The only way of discovering the limits of the possible is to venture a little way past them into the impossible. Because there's a lot of hype out there. And I hope I provided some practical advice for how these tangible AI tools can be used pragmatically and we can understand what they are. But I also know that I don't have all the answers. And I certainly don't have all the knowledge of what is possible. So sometimes it's useful to believe the hype and try and do the impossible. You might be surprised by what you can achieve. Thanks. I did save a few minutes at the end for questions, if there are any. I haven't been able to watch the chat while I've been talking. So, Rob, is there anything that's come in that I need to respond to?
I don't think there's any questions, but if you do have questions right now, pop them in the chat, and we'll try to get to them as quick as possible. While we're waiting, if anybody has questions, that's great. I'm going to launch a survey, and I put this in the chat. Blackbaud is going to award individuals with the top feedback from post-session surveys with golden tickets to BBCon. So that's a good prize. Travel not included, should mention. So I launched that survey. So if you could get in there and do fill that out, that'd be awesome. So we know, so we could give Thomas, his flowers on doing such a great job. That was an awesome presentation. And that's really all I'm seeing, Thomas, is just people saying wonderful presentation, good summary of AI and how it works. And personally, I love hearing about AI every chance I get because it feels like the Wild West in a little bit, but it's such a useful tool. And
I do see one Q&A. So how do you balance concerns like hallucinations against others like environmental impact and data bias, and how useful these tools can be? The environmental impact alone for LLMs is a whole nother discussion. The number of resources used to build, like the amount of power and coal burned and whatever else to create the GPT models is kind of insane. Like can power a small city or a small town for months. So there are those environmental concerns. I think then we get to how do we use them wisely. So we shouldn't just encourage OpenAI and whoever else to just keep building the next bigger and the next bigger and the next bigger model because I think we're at a state of diminishing returns. We should use the ones we have most effectively. It's hard to know what your environmental impact is when you're calling these things, if you're using an API. The closest analogy for green software is really how much it costs. So if you're getting charged 10 cents a token to use the latest version of GPT versus 1 cent a token for an older version, try them both out. Do enough experiments, do like 10 or 100 prompts and see, do you get substantially better results with the big one, or can you use the smaller and cheaper one and still get pretty good quality results? If you can, then maybe do that. Sometimes they respond faster, so you can get a better overall customer experience. I think that also gets to how are you hosting them? A lot of the times these are hosted in the cloud and you're going to call an API, but some of them, the smaller ones especially, are designed so they can be run on your infrastructure. So if you can host it yourself, then you kind of know how much power you're using on those VMs to host those models. So a lot of aspects of that for all the other concerns. For hallucinations, same thing. Sometimes the bigger models are able to have more information, but if it's very specific, again, it's that legalese question. Do you have a paralegal answer a question versus someone who has just a general degree? Find someone who has the most specific knowledge, or tell it the answer's in this book. It's an open book test. Just find it from here. So a lot of things to consider.
Awesome. All right. And I love that we have the GIF ability from everybody. So I appreciate everybody that has a great sense of humor and participated, and great questions and good feedback. Great crowd, great crowd. Thomas, we'll leave it at that. Thank you so much for your time and walking us through AI, and thank you everybody that attended. I think I saw we were up to about 150 people at one time, so popular session.
Great. Well, thank you,
All
Rob.
right.
Thanks, everyone.
Yep.
Have a good rest of your conference.
Take care. Bye-bye.